Part 1 of soil water. So here's the water cycle, a naturally occurring cycle, of course, but we certainly have done a number on some of the parts to this, especially with runoff and groundwater, all kinds of things we've done. So water is part of every living thing. It's in every cell. It's important in aggregate formation. It can be involved in erosion, and it's often involved in chemical reactions. It can be liquid, gas, and solid. It can move up, down, and sideways in the soil, and it is able to get to the top of the redwoods, which are the tallest trees. So this is just to show you that out of all the water in the world, most of it's salt. Only a very small fraction of that is readily available for human use, and even less for soil moisture, which plants need. So infiltration versus percolation. Infiltration is the water movement into the soil. Percolation is the water movement through the soil from the unsaturated to saturated zones. So infiltration rates, high infiltration would be 1 inch per hour. Very low would be 0.1 inches per hour. And of course, clay loam is going to be very slow. And the problem with having very slow or low infiltration rates, if you're using irrigation and if you're running it beyond the time it's going to take for it to actually infiltrate the soil, you're going to be wasting water and causing some erosion. So infiltration rates can be affected by the condition of the soil-air interface, bare soil, if you've got crusting, which is what you see here on the right, hydrophobic coatings, I'll talk about that in a minute. Soil management, if you've got cover crops or you've got compaction, here we've got a social trail, so that's very compacted right there. Soil properties such as soil textures, clays, slopes, and of course the rate of water that's applied. So hydrophobic soils are very common. That just means that they're afraid of water because of organic matter, and organic matter coat the soil particles when the soil becomes very dry. And you've probably seen this before, certainly in nurseries where you've got high peat content in potting soils. And I used to water plants for a living, and quite often if you had a situation like this, I would just add a drop of soap into my water bucket, and that would break the surface tension. This is all about surface tension. And you can buy wetting agents, although they get very expensive. Okay, percolation rates, poorly drained is going to be less than 4 inches an hour. Excessively drained, greater than 8 inches an hour. And so something you might consider doing, and I can post a video. On the next slide I'll show a picture of doing a percolation test. But just to let you know, capillary action is the ability of a liquid to flow in narrow spaces without the assistance of or even opposition to things like gravity. So here is a picture of percolation test, and I'll put up a video for that so you can think about doing that for your site. We did it in class last year, and of course that's not going to happen this year, but anyway. Water moves through the plant. It's the transpiration stream. It's like a straw that draws the water up from the soil. There's low osmotic pressure inside the root and then high on the outside, and of course that's got to be balanced, so that is able to push the water into the plant and then transport it to the leaf, and then it's transpired and ends up as water vapor. So osmosis is the diffusion of water through the membrane, such as a root hair, and it enters by osmosis from root hairs and continues until it reaches the xylem cells. And again, osmosis is moving from an area of high water concentration to an area of low water concentration. And I just wanted you to see this picture of infiltration. Of course, in an aggregated soil, it's going to be easily infiltrating the soil. In a compacted situation or a crusty situation, you're going to have a real problem with runoff. Here's another picture of the surface crust. The roots aren't growing very well. So the water cycle or hydrological cycle, it enters the atmosphere, it evaporates from oceans and lakes, etc. It's transpired by plants, it evaporates from soils, and then the two together, transpiration and evaporation, is called evapotranspiration. And here's a graphic of that. So you've got your trees and your grass that are transpiring, and then the soil, the bare soil, is going to be evaporating unless it's running off, of course. Here's another look at that. So you can prevent this by using mulches. Straw can be used, wood chips, of course, plastic, and while a lot of people cringe at this, it is a way to get the soil warm to grow your seedlings. Crop residue, plant material, things like ground covers can help with evaporation.